Right, hey everybody. We are going to talk about the arc flash today. Yeah. It's a field that it's a branch of knowledge that you absolutely have to know if you're getting into the business of electricity and power that's associated with that. All right. Now, so just to get your attention, and I'm going to place the reference links in the description. So because, well, we are required to do that, and of course, please visit those sites and give them the recognition that they deserve. I heard it somewhere. Where did I hear that? Okay. All right. So first clip. Yeah. It is a tree branch falling onto a power line. All right. Here is an arc flash. That is what is called an arc flash. It's one of the scenarios that you could encounter. It's a slow motion as well. I think this one says, "Hope you enjoyed the show." Wow. There you go. All right. So that's the one. Oh, cancel. Here's another clip that I'm going to play here. What do we see on this clip right here? It's a mannequin dressed up in a protective clothing that you're required to wear if you're working with certain amount of power. Okay. So of course that person should be protected because that person is wearing the protective clothing. Let's take a look at what's going to happen when an unwanted connection is going to happen. It happens. Right? So let's just view that a little bit. We have a train in the background. So it's a slow motion camera. Yeah, that person should be protected, right? All right. Yeah, looks very protected. There were other, some years ago, there were other video clips that were available that were associated with arc flash, but they were removed from YouTube, probably because of the severe content, right? So they're not available right now. This was a test. All right. So I hope I got your attention when it comes to this. Let me just close these links here so we don't get any unwanted sounds coming through by accident. All right. So just to give you a little bit more visual or more idea of what's going on here, imagine, well, you can, in GTA, Toronto area, and some other areas as well, some cities, you could see those streetcars. Right? The streetcar is basically just like a wagon of like a train car, right? It does have a lot of metal. That thing is quite heavy. Now it is getting its power from the wire that is overhead, okay? And just if I'm not sure if anybody would ride one of those. Now, when the driver steps on this a little bit less careful than other times, you can see that the whole thing just is being moved, is jolted forward with such ease that as if it had no weight whatsoever, right? So this is how much power goes through some of those wires. Imagine there is a whole train that uses electric traction that is overhead the train tracks. It's not just one car. So if you see some of those GO trains or other means of transportation that use the rail, so it's a whole train, right? And again, when the driver sometimes steps less carefully on that on the quote unquote gas pedal, the whole train just jolts that it can bolt you into the seat. All right, so it's this is how much power goes through some of those wires again. Now imagine that something went wrong, and by accident, instead of that power going into the movement of a train controllably, just imagine the whole thing just released at one point, all of the sudden. All right, so this is like a bomb exploding. All right, so there's no joke when it comes to dealing with safety that has to do with electricity. When power goes up, the safety measures that have to be taken actually go up, and some of the rules and regulations, they also have to go up to the point that somebody who is able to work on some of that machinery, they should have licensing and rights to work on it, same as if you were a pyrotechnician working on some high explosive devices. All right, so yeah, okay, yeah. Well, once in a while you will. This is 21st century. Electricity is a big part of our lives. So yes, once in a while you will know somebody who unfortunately had, was put through some of that stuff. All right. Okay, so let's take a look at some of the knowledge that has to do with the arc flash. Okay. Let me just get the PowerPoint ready here, and so you can see my pretty face. All right. Okay, so this was the first clip that I played for you. So we have seen that one. Then there are some other pictures associated with the arc flash. Now that transformer that blows here, the sound that's associated with that, it is just like highly efficient explosive. All right, so it's almost pretty much, not almost, it does explode like a bomb, right? Because there's so much energy concentrated in that one spot, right? We have seen this one here. Now, what is an arc flash? All right, an arc flash is an explosion caused by the release of energy generated by an electric arc. We do have some uses for electric arc, for example, in welding. So we are controllably producing an arc, electric arc across the electrodes in order to weld steel together, right? Or produce welding bonds, right? But what we're talking about here is the safety measures associated with the unwanted explosions caused by electric discharge, right? So basically it's a prevention, and just so we know what we're involved with, there's that saying that somebody knows enough just to be dangerous. You need to know more than that, right? So you have to know enough to not to get yourself into trouble when it comes to things like that, all right? So we'll talk about the arc flash and the boundaries associated with that, and we'll talk about the boundaries that were in 2015, and there was a slight change in 2019. I'm going to present both of the scenarios for you. All right, causes. What can cause an arc flash, right? Over here, there's some of the list, some of the items that can cause an arc flash: dust, water, impurities, contamination, corrosion, or animals. Right? Well, when it comes to dust and water, when things get dusty and dirty, polluted with some impurities, Just imagine dust combined with humidity, and if there is enough concentration of that, you have a conductor at your hands, right? And when there's dust across two terminals that are highly charged with electricity, at some point the electricity is going to find its way to flow through it, right? So it is important that well, there's certain type of maintenance that is involved with certain devices that are of high power. Right? Contamination and corrosion. Corrosion can cause arc flash as well, and animals. Devices that are highly dangerous when it comes to arc flash. There are some protective devices installed, guards and stuff, for the animals to not be able to crawl into that, because animals, they have no knowledge of electricity, and sometimes if one of those animals crawls inside a transformer or something like that, it can actually short. We do human flesh or animal flesh, we are conductive. Right? You can actually measure your own resistance with the ohm meter, with the digital multimeter that you have. Just make both of your fingers wet a little bit, and put your ohm meter at high level, high range, and just squeeze as hard as you can those leads, and you're going to see some resistance happening on the screen. So we do have a resistance, and if we have a resistance, that means we are conductive. If there's something like a plastic or PVC, it does also have resistance, but it has much higher resistance than we humans do, right? Or flesh. All right. Now, what else can cause an arc flash? A discharge from accidental contact, dropped or improper tools. So when you're working with around devices like that, tools should be handled quite consciously, and that's the descriptive I'm going to use. Over voltages across narrow gaps. Air does have resistance, and the more humidity in the air, the less resistance there is. Right. So if gaps are too narrow and there's too much voltage between them, an arc flash can happen between those two terminals. Failure of insulating materials, pretty much self-explanatory. Loose connections can cause an arc flash. That's why I'm putting such a high stress on you terminating. We're just terminating duplex receptacles right now up to this point, but why am I so strict about how perfect I want that termination to be? I want you to develop the habit. I want you to be conscious of that connection. It's just not just working on your kitchen table, doing a little project for elementary school anymore. You're supposed to connect when you're terminating. Connecting is whether it's a signal wire, or there's a reason for terminating signal wires properly, so the signal can travel properly. But when it comes to power, if you perform terminations that are not proper, all kinds of sparking and arcing can happen right at the connection, right at the termination. Right? Equipment failure, well, self-explanatory, and here is the one that takes the cake in a lot of cases. Unfortunately, workers that assume that electrical equipment is de-energized. Right? Whenever you're working on equipment that is usually energized, you have to make sure that the equipment is de-energized. How do you do it? Well, there are certain procedures that require you to perform. You gotta go to the circuit breaker or wherever the disconnect is, and you have to disconnect the power to whatever device you are going to use. Now, not only you're going to disconnect that, you also are supposed to make sure that that circuit breaker or that disconnect cannot be flipped back on by accident, by somebody who's just thinking, oh, why is this thing off? It should be on, right? And then around the corner, you just go and say goodbye. All right, so there are lockout procedures or there are attendants involved. Right, the best way would be a lockout lockout mechanism with tags and an attendant, just someone who just stands there, making sure that nobody even tries, not even think about try to put that to turn that thing on. If you don't see it, if something is around the corner or further away, the best thing is to have an attendant. Right? All right, the consequences. I hope you had your lunch. And these are not tattoos. All right, the consequences of an arc flash can include, all right, electric shock, severe burns, blindness, deafness, shrapnel wounds, long blast injuries, and of course, unfortunately, death can occur as well. All right, so we're going to examine some of that as we go along. All right, arc flash blast effects. There's a sound involved, right? Arc blast at 2 feet, right? It can go up to 145 decibels. What does that mean? Well, a jet engine at 200 feet is 132 decibels. And the human pain threshold by the ear is 130 decibels. If there's any musicians or pro audio persons around here, I think that I think it's a 90 decibels. If you're powering up a concert, doing a sound system at a concert, you're supposed to have a sound meter or the sound level meters, if the sound that's coming to the people's ears is higher than 90 decibels, but please verify that, it is actually illegal, right? Because it can cause hearing damage, and hearing damage is irreversible, right? You can just see what's involved when it comes to sound. Heat is involved as well. Arc flash. Yeah, someone should tell mother. Okay. All right. Heat. Arc flash up to 20,000 degrees Celsius or 35,000 degrees Fahrenheit. Okay, 20,000 degrees Celsius are that's a high temperature. The temperature of the sun is 5,600 degrees Celsius. So it's actually higher than the sun at the spot. All right, it's a bloody explosion. All right. All right, arc flash blast effects. Arc blast. Arc flash can throw a worker off a ladder. That would be a mild arc flash. Right? Can throw a worker into a nearby walls of equipment, right? Just like a toy. Right? What do we have here? 1,400 kilograms per meter squared, or 2,000 pounds per square meter of pressure on the body can cause, well, it can cause concussion, it can collapse your lungs, or it can cause severe internal injuries. Do not do that at home, kids, right? Projectiles can be thrown. It's just like explosion. They're structural elements of whatever the equipment is. Yeah, because Across you can you can create a mini sun. Yeah, okay. You can look at it that way, right? Projectiles can be thrown. So if it's an explosion, things can fly. All right. Now, what is the usual speed of a bullet that comes out of a barrel, like a regular rifle? Well, it could be 30-06 or 270 or 223. Usually, the bullets leave the barrel with the speed of 3 times the speed of sound, all right, which would be 3,000 feet per second. So just calculate that. Do some conversion there. You're going to have something close to that. So basically, as if there is something that's thrown at you, it would be with the speed of a bullet, right? So just use your imagination what can happen there, right? All right, there are certain the arc flash knowledge is regulated by these, well, we're in Canada, right? So we have Canadian Standards Association, Canadian Electrical Code, Occupational Health and Safety Act, and then there's U.S. National Fire Protection Association and Institute. So you can find rules and regulations that are mentioned in this type of literature when it comes to arc flash, right? CSA standard Z462, right? That you can also find there. Standard for workplace electrical safety in Canada, right? Now, CSA standard Z42 covers electrical safety program, arc flash hazard analysis, flash protection boundaries. We'll talk about those. Fault current calculations. So basically, fault current is just basically how much current will be available when a fault happens, right? Arc fault clearing times, incident in energy exposure, and required personal protective equipment. So some of that we will cover here today. Bill C-45, which is federal legislation amendments to the Canadian Criminal Code. Right, so I'm not going to read the whole thing, but what I want you to know is that you know, sometimes when you make a mistake or you do something wrong, you can cause somebody to lose money, or you can cause somebody to be annoyed, you can cause somebody to be upset. When it comes to electricity and high-powered electricity, you can cause somebody to be severely injured or die, all right? So when you make a mistake and you do something improper, then it basically falls under the criminal code, right? Canadian Electrical Code CSU rule, electrical equipment such as switchboards, panel boards, industrial control panels, meter sockets, enclosures, and motor control centers that are installed in other than dwelling units. Dwelling is basically where people live. Are likely to require examination, adjustment, servicing, and maintenance while energized. Shall be field marked to warn persons of potential electric shock and flash hazards. So basically those devices like electrical panels and things like that, there should be marked in the commercial environment, right? And there should be warning signs. The marking referred to sub-rule 1 shall be located so as to be clearly visible to persons before examination, adjustment, services, or maintenance. There are two types of electrical installations when it comes to that. One is the residential type of thing. So when you have the electrical panel, when you have your fuses and circuit breakers, you can come up there and flip those on yourself. But there is only certain power included involved when it comes to that. And then even then, you're not supposed to do anything there if you don't know what you're doing, right? But when it comes to commercial installations, there's the power that's involved is much greater than the one at your house. Hazard risk category levels. CSA Z462 has identified 4 hazard risk category levels in which are numbered by severity from 1 to 4, right? Let's look at some of that here. Hazard risk category is a risk category. Remember when we were talking about the hazards and risk? Hazard is a danger, right? What type of a danger, right? You can fall down, you can hit yourself on something, or something can hit you. That's the type of a danger. You can get burned by chemicals, so that would be a hazard, right? And the risk is a chance of that happening, right? So it's percentage of a chance of that happening. How likely is that to happen when you find yourself in proximity of whatever that's involved with that? So hazard risk category is a level of arc flash protection clothing you must wear to protect against minimum level of incident energy measured in calories per centimeter squared. So in order to you gotta put some numbers to some of the protection levels. So the risk is calculated based on calories per centimeter squared, meaning electrical equipment, depending depending upon the energy delivering capability under the fourth condition, can cause explosion or arc fault of a certain level. Mini lightning bolt, yeah. Measured in calories per centimeter squared. That explosion can deliver a certain amount of heat to a certain distance, right? Each level 1 to 4 is rated at a certain amount of flame resistance. So flame resistance, you're talking about the protective clothing. Now, what's a calorie? Right? Calorie is the amount of heat needed to rise a temperature of 1 gram of water by 1 degree Celsius. Right? It's a thermal energy. It's energy measured in calories per centimeter squared. How can we get 1 calorie? 1.2 calories per centimeter. So if you hold your finger in the blue part of the flame for 1 second, you're going to get 1 calorie, 1.2 calories per centimeter squared. So that's, you can put something to, we can put some imagination to that. All right, now personal protective equipment, PPE requirements. So on the left here you have the hazard risk category and the clothing protection and required minimum arc rating or PPE for calories per centimeter squared. All right, so category 1, 2, 3, and 4. Obviously, category 1 is the lowest, and category 4 is the highest. How to bypass food for for calories? Well, treadmill, elliptical, right? What's a treadmill? What's an elliptical? It's a piece of equipment in your basement that is used for you to hang your clothes on. Okay, that's it. There we go. All right. So, okay, let's get back to this thing here. Hazard, well, that's what I do. Right? Hazard risk category 1. Let's take a look at this thing. Arc-rated flame retardant shirt, flame retardant pants, and flame retardant coverall, 1 layer. Right? Minimum requirement 4 calories per centimeter squared. Category 2, arc rated flame retardant shirt, flame retardant pants, flame retardant coverall, 1 or 2 layers, and it's supposed to handle 8 calories per centimeter squared. We just keep going with that. I'm not going to read the whole thing, but you get the picture. Now the category 4 is the highest, right? Let's see, arc rated flame retardant shirt and flame retardant pants, flame retardant coverall, and arc flash suit selected so that the system arc rating meets the requirement of 3 or more layers, and it's supposed to withhold 40 calories per centimeter. That's a lot per centimeter squared. Right? That was basically that suit that the mannequin was wearing when put to that arc flash test. Now, when it comes to why don't we just say, okay, why do we have the categories, right? Why can't we just say have one that's the highest protective level and just make it mandatory so everybody wears that? All right. Well, the thing is that there's a little bit of a compromise that has to be established. Depending on the conditions, you might really, in reality, you want to wear comfortable clothes. When it's a hot summer afternoon, you're not going to wear a fur coat. All right, you're just going to wear a t-shirt and maybe some shorts and sandals and stuff like that, right? If you're wearing a fur coat, just like a winter clothing, and layer yourself up, then you're not going to be able to handle standing in the sun. You go to the beach like that, and people are going to look at you funny, all right? Plus, you might get some ambulance taking you away from that because you're just going to get a heat stroke. Right. So here's the thing. You want to wear the minimum amount of clothes so you can actually do the work. If you overdress yourself too much clothing, you're not going to be able to perform the work, but you'll be protected, right? So it's a reality balance between one and the other. Okay, so that's why we have the categories. Okay. All right, personal protective equipment, PPE requirements. All right, what is the PPE requiring us to do? Limit the incident energy level of the arc flash to 1.2 calories per centimeter squared against the worker's chest. You have to look at the label that states 1506 approval, ASTM, da 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 da. All right, so here's the label. Arc rating of the garment. All material in the garment should be fire retardant rated. Thread. So all elements in the garment. So it should be the thread that is used, the buttons, the insulation, the zippers, pretty much everything that is included in that garment should be approved for in such way. Right? And ASTM stands, because we're here, right? ASTM stands for American Society for Testing and Materials, right? ASTM Standards. What's the meaning of this? The group, well, just a bit of a history here. Oh, well, here, there I am. Yeah, it's a bomb-proof for receptacle. Wearing a bomb-proof suit for receptacle. Yeah, you're not gonna wear that, right? Yeah. So ASTM standards. What's the meaning of ASTM? So the group was developed a standard for steel used to fabricate rails. Originally, it was called American Society for Testing Materials in 1902. That's a year. Okay. Then it became American Society for Testing Materials in 1961. It changed its name to ASTM International in the year of 2001. Okay, and added the tagline Standards Worldwide. Okay. All right, personal protective equipment, PPE requirements. This is what the hazard risk category 1 looks like. Then we are stepping up the protection, until we get to the category 4. All right. So, yeah, I might ask you some of the questions that are associated with that on the test. So you might want to keep these posted lecture notes. All right, tasks with potential arc flash. What kind of jobs are you going to be doing that might put you in the risk, or you could be involved with the hazard of the arc flash? All right, so operating a switch or a circuit breaker, that can put you in in danger, right? Did you ever think of that? Notice that the proper way of actually operating a circuit breaker over higher power is you're not supposed to come to that circuit breaker. Let's see, this is a circuit breaker, and just come over and just flip it with your face right at it, right? There's a reason why the circuit breaker failed or tripped, right? If it was just some momentary failure or overload or something, everything is fine. Yeah, okay, probably nothing is going to happen. But if the fault still exists there, operating the circuit breaker can actually cause an arc flash. So you're not going to put your face. You're going to actually use your less dominant hand. In case you lose a hand, you're going to lose that one, all right? So, and you're going to try to put your face away as far as possible from that, and that's how you flip the circuit breaker, if you have to do it manually, all right? Inserting or removing a circuit breaker, changing a fuse. We're not talking about that little fuse that you're putting, although all precautions should be taken when you're changing a fuse in your electrical panel, or flipping a circuit breaker, depending on what kind of panel that is. But we're talking about the bigger ones, right? When you're changing that, when you're removing that circuit breaker, or you're putting one in, again, you're making a contact. All of a sudden, the electricity is going to start flowing, so that can actually cause an arc flash. Operating an enclosure door. We'll look at some of that. Well, over here there's a dude that's opening an enclosure door, right here. Okay, that can cause an arc flash. removing cover, hinged or bolted, or testing for voltage. Remember when we had the different categories of voltmeters or multimeters that we're talking about in the very beginning of this course? That's why different meters are designed to handle different type of power. If you have a little kind of a consumer, if you can say that, rated multimeter, and you're going to measure, try to measure something that is of higher power, that thing actually can blow up in your hands, all right? Because it's not designed to handle that, right? And what do they look like here? Hinged or bolted covers. Well, there's a hinge, just like the door, and you open it, so that's a hinged cover. And this is a bolted cover, right? There's a bolt, there are bolts. Yeah? And this one is both. There's a hinge, and there are also bolts to hold that cover. How can that cause an arc flash? Well, there could be some elements that are resting against those covers, and once you make some physical movement in there, things can happen. All right, so that's why always take a precaution when you're doing this kind of jobs. Right? Arc boundaries. Okay, so now we're going to, I'll show you first the arc flash boundaries that were implemented up to 2015. All right, now replaced with the 2019 versions. Why am I showing you that when things have been changed? Well, I want you to know, if it was something that was implemented 30 years ago, yeah, okay, obsolete, right? But I just want you to know, because it's so recent, I think it's a good idea that you know what was up to now and then from now on, right? Not too much of a change, but there's a little bit, right? So there are boundaries. When it comes to high-powered electrical enclosures or equipment, there are boundaries, and boundaries are basically the parameter on how close can you get, how close can you get to the equipment. All right, I'll get it here. Can you send an email regarding not being okay, I'll look at that later on. Okay, let me just copy that here. Give me a sec here, just so I don't forget. Okay. Give me a second, guys. Save as. Yeah, because sometimes the desktop here. Save. All right, good. Got it. Gotcha. All right. So now, notice when we're going to analyze those boundaries, I'm not going to specify a distance, right? Because different equipment could have different distance that you can get close, and it's going to be considered as the type of boundary of how close you can get to it, right? So there's no distance. Is it 10 meters or is it 15 feet or something like that? No, it can vary from the type of equipment, from the situation. All right. All right. So the boundaries. The furthest one is the gray area. Now that was up to 2015. So the gray area, arc flash protection, then we have the limited approach, restricted approach, and here's the red zone. If you're standing in the red zone, it's equal to being in contact with the equipment if you're standing this close, right? So let's take a look at this thing. So here is the gray boundary, all right? See, I'm going to analyze them one by one a little bit, all right? Gray boundary. At this distance, PPE must be worn to prevent second-degree or greater burns if exposed to an arc flash. It's the outmost boundary, it's the furthest one, furthest away from the energy source. Unqualified persons can approach unaccompanied. So if you're basically, well, horseshoe kind of a maker or a baker or anything else, or seamstress, nothing to do with electricity, you can stand this far, right? And you don't have to be supervised. Now, unqualified person can approach unaccompanied. Okay, unqualified person might only cross this boundary unaccompanied, but accompanied in a company of a qualified worker. So you can cross that boundary, right? Should an arc flash occur, the person exposed to the blast would be subjected to the heat generated by the flash, resulting in a second-degree burns, which would be the holding a cigarette lighter, right, for 1 second to your chest, right? So that's the outmost boundary here. Two arc flashes strike in the same place twice. I don't know. I never counted them. Now we're moving to the green area here, right? Limited approach, only qualified persons within this boundary. Unqualified persons might enter when continuously accompanied by a qualified worker, appropriate level PPE, and trained for the task. So you're going to have a little bit of a briefing of what you can do, what you can't do when you are this close to the energy source. All right, now yellow. All right. Restricted approach boundary, only qualified worker might get in there. Appropriate PPE, properly trained for the task to be performed. This boundary is restricted to unqualified personnel. If you're not supposed to be there, if you have nothing to do with that, and if you're not trained, if you're not qualified to be there, you cannot be there. All right. Exposed energies, electrical conductors. So that's considered to be exposed energized conductors or circuit parts, 50 volts or more. Right? Now requires approved work permit with a written plan. So here's just as we were talking about yesterday with a confined space. When you are there, it actually should be documented. You should have a reason to be there. You can't just yeah, I'm qualified, so I'm going to stand there because I can. No, you can't. You have to have a reason to be there, and it should be documented. Right? Requires approval plan. The written plan should include well-defined procedures to prevent exposure to shock hazards. Right, and here is the red zone right here. Prohibited approach boundary. Energize live part, considered the same as making contact with the live part when you're standing that close to the energy source. Distance varies from direct contact to several feet, depending on the voltage and depending on the situation, depending on the type of equipment there, right? Now, this was up to 2015. Now it's replaced with the 2019 version. So here's the difference, right? There is less zones, right? The red zone is a little bit wider. So there, instead of having 1, 2, 3, 4, we're going 1, 2, 3 only boundaries, all right? So arc flash boundary, yeah. So let's take a look at this thing here. Arc flash boundary, right? Arc flash boundary or restricted approach boundary changes depending on the potential of arc flash hazard. Okay, so that's why the distance. The arc flash boundary is calculated. To the see here's that thing repeats all the time. 1.2 calories per centimeter square of incident energy. All right. That's the distance where a worker without PPE would receive a second-degree burns. Right? So it's that far. All right. Well, distance varies. All right. Sometimes this boundary is the furthest one from the exposed equipment. Other times, the limited approach boundary is the furthest out. Right. Now, when arc flash boundary is the furthest away, it becomes the line that no one should pass. No one shall pass, Monty Python, right? Without training and PPE. All right. If the limited approach boundary is further out, then that should be treated as the line no one should pass without training or PPE. So here's the furthest boundary here that is marked. All right. Limited approach boundary was here we're talking about the orange level kind of a thing. So it's yellow, orange, and red, right? Moving towards the energized exposed equipment, you will find the limited approach boundary. Okay, so here's the limited. All right, so here's the arc flash boundary. All right, arc flash boundary, then limited approach and restricted boundary. All right. So we're talking about limited. Moving towards the energetic, you will find a limited approach boundary. Within this boundary, it is still possible to be exposed to the shock hazard. Appropriate PPE should be worn by qualified workers in the limited space between the limited approach boundary and the restricted boundary. Okay, I gotta read it a couple times. Non-qualified workers should stay outside of this boundary unless wearing proper and being escorted by a worker with specialized training. So we can get a little bit closer being unqualified, but you should be trained or debriefed, and you should be accompanied by a qualified worker. All right. I'm not sure who would want to, why, but it's the rules, all right? Maybe just a nature observer of electric equipment, right? All right, so then there's that restricted boundary. Here is the red zone right here. This area closest to apprentice. Yeah, okay, apprentice. That's a good. Yeah, thank you. Good call, Josh. The area closest to the live exposed equipment is within the restricted boundary. In order to pass this boundary, you must be a qualified worker with the proper training and PPE. If you need to perform work on Energis equipment, you might also need a work permit and documentation. All right. So basically, that's it for today. Okay. Well, we made pretty good time here. So yesterday we did the confined space that has to do with the safety with that, and today we have looked at the arc flash. Now, this is just a kind of a brief look at that. Now, when you find yourself work, depending on where you work, usually it would be within the industrial electrical work. Then you will have to get the arc flash training by a government regulated or government approved agency or a person, and you're actually going to be certified. Things change from year to year, all right? So new regulations, new rules. So you might actually have to go through periodical training when it comes to arc flash training. It's a very common thing. So when somebody talks to you about arc flash, now you know what they're talking about. It's not just some sort of a descriptive that somebody wants to describe something, trying to find a word, but no, it's actually a technical term, and that's what it's associated with, which basically what we're just talking about. Okay. All right, so that's it for today. Now, what was it here? Benjamin. Okay. Yeah, I'm just going to look at your email because I just had a lab with you guys a couple hours ago. I had to drive to St. Thomas and set up the equipment and all that stuff. So I didn't have a chance to go through my emails, but I will do so right after this class, which will be in a couple of minutes. All right. So that's it. No, I don't live in St. Thomas, but my equipment here, that's my office that I use for teaching, it is in St. Thomas. Right? So I actually travel further when I do online teaching than if I were coming to school, because I live just around the corner from Pancho College. Right. Cool. All right, guys. And well, this is week 11. We have 12, 13, and 14. We pretty much ran out of the materials that were supposed to be presented to you. So we have a couple more weeks that we can cover some other materials. I'll find something to maybe to review or to practice other things. And the reason for that is that before COVID, some of the time was designated for writing tests and doing reviews and whatnot. And now when I put those tests online with the COVID kind of times, then we ended up with some extra hours. But I'll try to find some interesting materials for you. Right. Hope you're enjoying the course, and I will see you also next term with that course. It's called Network Cabling. We're going to have some more fun connecting communications equipment. Right? Okay, that's it for today. Thank you very much, and I'll see you when I see you. Bye, guys.